So welcome to the dual fuel heat pump panel. I'm Jeff Gorey, I'm on IAE. I'm going to say again, if you're not an IAE member, I would urge you to consider becoming a member. But today we're here to talk about heat pumps and why to care about heat pumps. With us today, I'm going to give a really brief introduction, but it's Grimm and Paine. And I'm just going to hand it over to you guys and let you talk about yourselves and talk about heat pumps. So.
All right. We took a vote. Sly said I had to go first.
You drew short straw.
So my name is Paine. I work for Slipstream. We're a nonprofit that works with utilities, contractors, and a lot of other market actors to try to initiate and transform markets to develop energy efficiency plans and make it attainable and apply them as equitably as we can. So today we're really going to talk about heat pumps and specifically dual fuel heat pumps and why we should care about them. A lot of times we'll tell people that heat pumps are just air conditioners that can run backwards. But really, an air conditioner is a heat pump that's limited to cooling. That's the only thing it can do is cool. So why would you want an air conditioner if you can't heat with it and it has that capability? Heat pumps really efficiently provide heating and cooling. No matter what model you're looking at, even the most basic one, if you spend $1 on electricity to run it in the heating mode, you're getting more than $1 worth of heat into your house. They're always over 100% efficient. So heat pumps, especially in dual fuel, are going to be able to improve grid resilience. You've got a fossil fuel backup unit for when the heat pump isn't cutting it, or if you have a limited grid, you guys can initiate a demand response and swap back and forth on what's drawing your peak load at the time. So dual fuel is really a great place to start. There are a lot of opportunities in Iowa. 76% of Iowa homes have natural gas or propane. 83% use a furnace as their main heating equipment. So this is a forced air market already. You've already got the existing infrastructure. You got furnaces and air conditioners in over 80% of your homes. Dual fuels really, they offer benefits to utilities, distributors, contractors. It's a win-win. There isn't a scenario where you have a natural gas furnace and AC that you can't put a natural gas furnace and a heat pump in. You could put any other fossil fuel, propane, fuel oil, if it's forced there, you can put a heat pump with it. It's a very versatile, easy to implement solution. So really taking a closer look, the difference between all electric and dual fuel, the only difference is your backup heating source at the inside unit. You still have your natural gas or fossil fuel furnace. You have your indoor coil, and then outside you have a heat pump rather than an air conditioner. Air conditioners and heat pumps look identical. There's not a very big difference in even the appearance of them. Most of the modern heat pumps may have a horizontal discharge rather than a vertical, what you're used to. But even modern air conditioners are coming out with horizontal discharge. The more efficient you go, the more different it looks, the larger it might be, the smaller it might be. It's really gonna make a big difference, but you're not deviating from the traditional path. You're just enhancing it. You're making it better and more efficient. Really, dual fuel heat pumps are gonna be limited by the type of unit that you buy. So you have the traditional single or two-speed system. We have our modern inverter-driven systems. There are some standalone inverter-driven systems, which Sly is going to talk to us about later. And then you have your multi-zone and inverter-driven systems. And each of those have their own little application and their own little nuances for installation. So contractor education is a huge key to being able to deploy this, and that's a really important step because you have everything from a low to a moderate increase in price or a high increase in price. So they're really out there and they can fit every budget. Anyone that owns a heated and cooled home that has to replace a system, there is an affordable option for a heat pump.
Can I ask,
Mm-hmm.
let's say it's your home, on your budget, which system do you choose?
I'm special. I've been a plumbing, heating, and cooling contractor for the last 15 years. Because of that relationship that I have built over those 15 years with different distributors, I have not had to pay for equipment to install in my own home in 15 years.
Fancy, man.
So I do have a higher tier product. I have gone to folks' houses that are on financial assistance. They're getting aid from a weatherization company to implement a dual fuel solution. We did a 95% furnace and a 14 SEER heat pump, set it to the capacity of the units for lockout. So the thermal balance point, or the amount of heating load that the heat pump could actually handle before we swapped to natural gas, which just ended up being around 30 degrees in my hometown of Springfield, Missouri. But that cost was an $8,500 complete install. Half of it was paid for through the local weatherization program, and the homeowner, I financed the other half of it for them. And then I've had homes where the folks own a large business and they've spent $32,000 on a dual fuel system. So there really is a large range. And considering that the average price in America for a heating and air replacement system is $7,000 right now on a national average, $8,500 for a dual fuel system is not outlandish.
So, to build on that question, not to interrupt you, because you guys are going, what's leasing most commonly put in? Are you seeing air source heat pumps with a gas backup or with electric backup? Or?
So it really depends on the utilities that are available.
Sure. We both work for utilities, so that's why I'm kind of.
So if
we promote these things like crazy.
If natural gas is available, dual fuel is typical. A good 70% of the sales are going to be dual fuel applications. When natural gas is not available, it's going to depend on what the existing furnace heat type was. If it's propane, a lot of times folks would go dual fuel, but my lockout temperatures would be down around 5 degrees, which in Springfield, Missouri, we might see that for 3 days a year. But then when you get a little bit further out, depending upon propane pricing, people were going full electric very easily, especially since 2017. They want to be out of that delivered fuel market and the volatility of it, because you run out on a Friday and you can't get filled back up till Monday. You basically have no heat all weekend and you're paying an arm and a leg for it. People wanted out of that, so they did go all electric. And that was at least 50% of the sales that I had done in rural areas where no natural gas was available and they had propane as an existing backup.
Do you have a dual fuel rate, like a cheaper?
We have a better incentive on the rebate, because we have the option of Grimm management. Like he said, we can make them go to that gas.
We have a different rate, and if it's just a heat pump only, it really doesn't cash flow for them to put in a second meter, a second panel. You know, obviously we would probably lean more towards trying to, eventually we'll have smart thermostats and controlling them, and then incentivizing them, you know, semi-annually or something like that. You know, but our old system with being a metered kilowatt hour reduction, you know, per kilowatt hour, you know, let's say it's half the price, their investment into all the behind the scenes is way more than they're gonna get. It's gonna take forever to pay back that initial.
That brings us into a wonderful thing. So in 2019, Slipstream conducted a dual fuel heat pump monitoring field study. So we monitored 8 systems, everywhere from Grand Rapids, Sault Ste. Marie. Not from Michigan, thank you. So the goal was to model cost. All of these were propane backup, and we monitored propane offset and annual savings because of it. We did also monitor greenhouse gas emissions, carbon emissions, but I'm really going to focus on the return on investment for the homeowner, because that's the most compelling reason for anyone to do this. If it won't pay for itself, why do it? So the 8 homes, Greater Grand Rapids region, all 8 sites are pin dropped there. So big thing, they all had different switchover strategies, different lockout temperatures, and different control strategies for each of them. I do have a table that we're gonna, right here. So the very first column after the sites is the temperature that we locked out the heat pump, and you'll notice that site 4 and 5, one of them was a variable speed, one of them was a 2-speed, but they did not lock it out. They used the thermostat to monitor the home temperature, and the thermostat decided based on its own logic whether to run the heat pump or the natural gas or the propane backup. So really just thinking about that, keeping in mind sites 4 and 5, you have a variable speed capacity heat pump and you have a 2-speed. And then the other one I'd really like to call out is site 8. That's a single speed 15 SEER efficiency heat pump. So that's a pretty typical entry-level heat pump in today's market. So it really comes into play when we get into this cost effectiveness. Your incremental cost is the price difference between the bare bones basic replacement and what they spent on what they put in. So they spent, site 4, $2,600 more, site 5, only $900 more than a furnace and air conditioner. And then site 8, it was only $600 more than a furnace and air conditioner. But you look at the annual heating savings, the annual cooling savings, the propane reduction, and look at how many years you have to own the system for it to pay for itself, just through savings alone. That's not a rebate, that's not a utility incentive, that's not a lower rate for any of these things. That's just the savings from the system being installed.
So how do you explain the higher paybacks though, like that 9-year and 7-year?
Higher incremental cost, and the control strategy didn't allow for as much propane reduction.
Was the higher incremental cost because of the contractor or what, or equipment they bought?
The type of equipment that they bought,
Okay.
The efficiency rating of the equipment that they bought. But each of those units had a different control strategy. But you notice the sites 4 and 5 had a 2-year and a 3-year return on investment. Those ones did not have a lockout. They used the logic of the thermostat to control which fuel source it was using based on comfort in the home, its ability to meet the set point. Site 4 still had a significant reduction, and if we back out, site 4, you were variable speed with no lockout. Site 3, you were locked out at 30. That was probably our highest one, and that had the longest return on investment. And then the other thing that I really wanted to point out was site 8 was a single stage heating and air or heat pump system matched with a furnace, and you still had a 1-year return on investment. just on propane savings and cooling savings, because you only save $4 annually in cooling, but you saved $600 in annual heating savings. You were going to spend money on a heating and air system anyway. You spend an extra $600 and you got that back in the first year. That's pretty amazing, isn't it? If you guys actually want to see that QR code in the right-hand side is a link to that full study report that we have published and publicly accessible. So feel free to go ahead and do that. But the key takeaways of that were that people were really happy with those heat pumps. They saved money and it worked for them. I thought that was like a very valid thing to bring to you. Yes.
Do you know if any of the places where you did the study, do you have residential demand charges built into their rate systems?
I know that some of them had time of use charges, but I don't know the particular details. I am pretty sure that some of that is covered in the more in-depth survey. I just don't recall it off the top of my head, as well as others who were involved in that, because I didn't work for Slipstream at the time. I was still a contractor.
They don't happen to have the same data with natural gas by chance?
No, it was propane
Just
only.
propane.
We do some modeling work.
I'm just curious what that would look like. Obviously, it wouldn't be as great, but but still.
Yeah. So the return on investment period is longer for natural gas,
Sure, yeah.
but there is still significant savings dependent upon
Well-
how you set up the balance point.
Yeah.
I'll show you some natural gas stuff in
Okay.
mine.
All right. Did y'all, were you able to get the study already? All right. So the next thing I want to bring up is a project that Slipstream is working on with CEE, the Midwest Energy Efficiency Alliance, and Elevate. We have formed the Midwest Air Source Heat Pump Collaborative. This is funded by PNNL, and our whole objective is to cross-pollinate program best practices between regions throughout the Midwest. Rate design for heat pumps, workforce development, because that's going to be one of our biggest obstacles, and regional market transformation strategies to kind of get everybody kind of moving in the same direction and coordinated in their efforts, so that folks that have family in Indiana and family in Michigan aren't hearing different things about heat pumps. They're hearing the same messaging. So that if you're in part of Iowa served by one utility and in the other part served by another, you're still hearing the same cohesive messaging. It'd be really nice to get you guys to coordinate and look for that with us. We'd love your participation in it, and we do have some upcoming webinars that will be on Mia's website, Slipstream's website. We're going to go ahead and promote those as they come up. Those are a nice little picture of all the states that we're covering, and we'd be glad to get your feedback and participation throughout this whole process. So, bringing up some no regrets, things that you can do to create heat pump market interventions. Contractor training and education is a big piece. There are a lot of contractors out there that had experience with heat pumps 30, 40 years ago when they were still single stage and you had the size for cooling. Because one of the biggest things that makes cold climate implementation of heat pumps so hard isn't just their ability to heat, it's the gap between your heating load and your cooling load. That makes a big difference, because if you size for that heating load and that's the only way that you can run it, you can't effectively, comfortably cool the house with that unit. The new modulating inverter-driven systems and multi-stage, they're going to be able to stage and modulate to handle that cooling load, which is a lot less than your heating load, but then still effectively ramp up and meet your heating load as well. So you can do a lot better job with today's equipment to meet those cooling demands and your heating demands. And that has been a huge game changer in the heat pump world. Contractors are not always willing to listen to that because of their negative experiences that happened 30 years ago. So there are things that you can do to prove it to them, sharing case studies. A few of the utilities we work with are doing product ownership programs where they're sponsoring the purchase of equipment. The manufacturer discounts it, the utility picks up the rest of the bill, the contractor gets a free piece of equipment to install in their own home and experience, or install in a client's home and experience. And the only money that they're out is the cost of install and their time. So that's a really nice way of swaying hearts and minds of contractors. I mean, nobody wants to spend or put a quote in front of one of their customers for anywhere from $12,000 to $24,000 and have it be an experiment on that customer. They want to do it in a safe place where feedback can be fixed. You guys are already talking about your utility program design and incentives. The more conversations that happen and the more in alignment they are, the better it is for your customers, the better it is for you, and the better experience you're going to have dealing with your customers. Customer education and support is a huge piece as well. These customers need to know that a heat pump is going to be different than their natural gas furnace, or their fossil fuel furnace, or their wood stove that they're so used to heating with. The temperature rise out of a heat pump is a lot like an air conditioner. You're only going to get a 20 to 30 degree temperature change through the air in its best days, but 20 to 25 is very typical. And if you think about that, if you're heating your home to 70 degrees and you have 70 degree air going through your heating system, you now have 90 degree air coming out of your vents. You put your toe over that vent, or you're standing in front of your kitchen sink washing your dishes in the middle of winter, and you have 90 degree air blowing on your toes. That's 8 degrees colder than your body. That's cold air. But it's keeping your home comfortable. You just don't want that cold air blowing on your body because you're used to that natural gas or that wood heat or that fuel oil heat that was pushing 120 to 135 degree air out of that vent before. So you do have to educate them that it's different. And that's a huge thing. The other part of education is that they need to know that heat pumps go through defrost cycles. Air conditioners, they're effectively dehumidifying the air. And even in the heating mode, your outdoor unit is colder than the outdoor air to be able to absorb heat. Moisture in that air is going to go across it, and it's going to form ice. As that ice forms, it stops air from moving across that coil, and it needs to be melted so that you can get better air exchange again. That defrost cycle can be shocking the first time you see it. I have had phone calls from insurance agents that are auditing a home that they're insuring, and they just happen to see the defrost cycle, and they call the homeowner and say, "Hey, your air conditioner's on fire." They don't know it's a heat pump. The insurance agent ends up on the phone with me because I installed it, and I'm like, "Yeah, that's a defrost cycle." So I'll go outside at my house, record a video of me initiating a defrost cycle, and they watch it happen. And now that they know that I can make it do that, they're okay with it. But it is unnerving the first time you see one. The very first time I saw one, I was like, "What the heck is this?" And I'd gone through a heating and air school. I had worked on air conditioners. I had never seen that before, and I was scared. So it's very different. Heat pump contractor designations, that's an education system to promote contractors to know how to size, install, and appropriately set up and control heat pumps. That's very important for your customer quality and to ensure savings. That's one of the biggest things. So workforce development is a huge barrier for contractors. There are not enough tradespeople out there, whether it's an electrician, a heating and air tech, a plumber, a carpenter even. If you guys call to get a repair on your house, you're usually waiting a week if you want to make an improvement or something like that. Heating and air contractors are really overwhelmed and overworked, and they're not sending their guys to training because they can't afford to take the time off. They're going to lose customers. Entry-level workers is a huge thing that we need to push for, advocate for, and apprentice-style learning to kind of accelerate them, to give these contractors the ability to send their seasoned veteran technicians to training to change their business models. They're not going to do it if they don't have a pool of qualified workers to start with. So that's a huge thing that they need. And I don't care what trade it is, if we're trying to change the world, we have to support those trades. Field validation in emerging tech applications. We just showed you a dual fuel study. You're all going to take it, learn something from it, and funding those and producing those and spreading it, whether it's through consumer education, contractor education, or just market actor education. It's going to be of a huge benefit for them to see evidence that these things work. That's one of the biggest key pieces that are missing. There's lots of evidence that they work in this place or that place, but they need to know it works here in Iowa where your customers are. They need to know that. And with that, I'm going to turn it over to Sly.
Thank you very much. No, you're good. As Jeff said, my name is Sly Grimm. I actually work for Mitsubishi Electric, based out of Des Moines. So for those of you that are in the area, I live over by Easter Lake. Wanted to talk today about a specific example of a dual fuel heat pump. My territory for Mitsubishi, I actually cover Iowa, Nebraska, and South Dakota. So not very warm territory, and a lot of rural contractors. So, what you were saying about developing some of these contractors and making them understand really resonates with me, because we still have a lot of contractors out there that think 30, 40 years ago technology, it doesn't work, it's fine till it gets cold. That's not the case anymore. So one of the things I wanted to go over today was specifically a new dual fuel system that we have to kind of give you guys a real world example of a product that's available from a manufacturer. So for us, Mitsubishi, we've just released what we call our IntelliHeat system. So what our IntelliHeat system does is it allows to go over any furnace. So a lot of manufacturers right now have a product that pairs with their specific furnace. So it's limited in retrofit applications, as well as you have to have a contractor that only installs brand X in order to do it. When we designed our product, we don't make furnaces. We don't plan on making furnaces. We've been an all-electric heat source since our entry into the market in '82 when we came into the United States. We knew that a big hurdle for us to continue growing as a company was getting into some of these dual fuel applications, because as you had the question before about all electric versus dual fuel, we've been an all electric heat source since '82 when we came into the market. At the end of the day, it's still a limited market. As Zach showed, 80% of the population in Iowa has gas of some sort in their home. 80% of people asking them to switch to all electric, probably not going to happen, right? At the end of the day, here in the Midwest, people still like having gas as a backup. No matter what slides I show to contractors and show them we can do 100% at 5 degrees. We've got a unit that does 100% at -5. We're releasing one this fall that'll do 100% at -10. It's going to be rated to -22. We don't get much colder than that in the state. But having that gas backup is going to be huge. So for our product, it's going to basically go on top of any furnace and have a lot of different installation abilities: upflow, downflow, left, right. For those of you that have a little bit of knowledge about how blower motors work, we can go over what's called a PSC blower motor. It's a single stage. It's what blower motors have been as long as there's been blower motors, all the way up to an ECM, so variable speed as well. So to have that flexibility, there's really not an application that we don't fit into with a product like this. And having the ability to do it that meets the DOE's cold climate challenge. So this product does 100% at 5 degrees with a 1.75 COP. So very, very efficient. And that's at 5 degrees. The warmer it is, the more efficient we get. One of the things you talked about was discharge temperature on that. Not all heat pumps are created equal. For us at Mitsubishi, our goal is to have a 40-degree delta T across the coil. So if we're bringing in 70-degree air, our goal is to be pushing out 110-degree air. At worst, at 5 degrees or at negative 13 is what I look at a lot of times, we're doing about a 30-degree delta T. So it all depends on what heat pump you're using. There are absolutely some that average that 20 degrees, but depending on what you're looking at, there are ones that do more than that. So what this does for us, it puts us in jobs we never got into before. It allows us to go into that rural area where they want to stick with their propane or they've got a natural gas. They're not going to pull the meter. It gets us into that job that we've never been able to before. It extends those shoulder seasons with higher COPs. That furnace is at best 98% regardless of what the temperature outside is. We're running at 45 degrees, running over 3, almost 4 COP at certain times. So 300 to 400% efficient. And then as we get colder, we have the ability then to switch over by a couple different factors. It really gets us into that partial electrification or full electrification depending on what they want to do. We have all electric air handlers with electric backup as well. Conversation for a different for a different day. Today we wanted to focus mainly on the dual fuel. But even partial electrification is better than no electrification, right? It gives the homeowner some flexibility and some options. And what really makes ours a little more dynamic than some of the other products out there, he talked switchover strategy as part of that heat pump study that he did. Our switchover strategy gives the consumer 2 different options with this. The first one is we monitor the return air temperature. And when we fail to raise the return air temperature, so we're not keeping up anymore, we're not sized appropriately, we switch over to a gas backup. That's how a lot of dual fuel systems work. They're either watching the thermostat or they're watching the return air temperature, and they switch over when it can't keep up anymore, because it all depends on the sizing. We take that a step further. We give the end user, whether it's the contractor or the consumer, the ability to choose based on an economic balance point. So we're developing a tool that is going to look something similar to this, but basically you'll plug in the cost of gas, the cost of electricity, the efficiency of the furnace, and the efficiency of the system that you're using with us, because we have different options for our efficiency on it. And it will say at this temperature, you're better off switching to gas than using electric. It gives you a lot of flexibility on it, and then we show payback as part of that too. So yeah.
So you're developing that tool.
Correct.
Is that for you or for me or?
It will be for the contractor to use. So it'll be available on our website, My Link Drive. That's where all of our technical data is housed. I think the concern is giving that to the consumer.
Right.
That may be a little bit dangerous.
Right.
The way I'm selling it to contractors is once this tool comes out in the next 30 to 60 days, we should have it out. And this product has only been available for about 45 days right now anyway. It's been in field trials for 5 years. So I've got colleagues that have had it for 5 years. I'm going to show you my personal unit. I have this in my house in Des Moines. I've had it for 2 years. We are very slow to bring things to market at Mitsubishi because we want to make sure that we've got all the kinks worked out before we do something different with it. Yeah.
Is there a fail-safe on that? If you're running off of fuel costs and your house also then comes down there costs -35, is there a fail-safe on that?
Absolutely. We're always watching capacity no matter what.
Okay.
So if I set, we have different economic balance points that we're going to be able to do. We have 32, 27, 11, -5 and -13, I think are the 5 that we can do. Off the top of my head, I know I'm off a little bit there, but that gives you a rough idea. I'm going to show you 2 different houses that have this in it. One is mine, one is my colleague Kevin DeMaster. Some of you in the room may have met him before. Kevin has his set at -13. He wants to run that thing until it can't run anymore. I have mine set at 9 degrees. So 2 different switchover temperatures. Kevin's doesn't keep up to -13. I think he said like -10 is about where he switches over. But it'll run all the way down until it can't keep up, then it switches over. Because he wants to wring every last ounce out of that heat pump, because he's actually having some utilities do some monitoring on his to see a real world example. So, but yeah, we're going to look at payback as well on that. One of my favorite things with heat pumps is that if it doesn't make dollars, it doesn't make sense. That's why you do this, right? I've been in the industry for almost a decade at this point. I've been around heat pumps literally my entire career. Very proud to say I've never sold a furnace in my almost decade in the industry. It's all been heat pumps, and that's how I've been in sales the entire time. That's how I've sold heat pumps is, like I said, if it doesn't make dollars, it doesn't make sense. There's a lot of benefits to doing this, all the way from the utility to the manufacturer, to the contractor, to the distributor, but the homeowner as well. gives them a comfortable product that saves them money. So a couple different job sites that I'm going to go over with you guys. The first one is in Oconomowoc, Wisconsin. This is my colleague Kevin DeMaster. So this is his job. This is the day they did the install of his. His is actually, so his house was built in 2005. His system was 17 years old. There was no HVAC problems. He just wanted to do a field trial with this system. Mine is here in Des Moines. My house was built in 2012. At the time, it was a 10-year-old system. No HVAC problems in mine either. Once again, I wanted to do a field trial. I'm a huge believer of, you put these in your home, you live with them, you understand them better, and you do a better job of selling them at that point. So, as you can see, both units are side discharge units. This is his right here. This is his old system that's getting taken out right there.
What's that little guy to the right?
That right there.
It's like a baby.
So he has a single zone system for, he has a 3 seasons room that he turned into a 4 seasons room.
Yep.
So entirely separate system. Before that, that room had no heating and cooling in it.
Yep.
He has a special needs son.
Okay,
And
yeah.
he loves sitting in that room, and it was kind of a sticking point. His son didn't understand why he couldn't be in there in the winter because it was so stinking cold.
Yep.
So he put a single zone system in that 3 seasons room.
I've never
So-
seen a little guy like that. That's funny.
Yeah, depending on what you're doing, we have single fan and then double stack fans, depending on the size. So the smaller sizes, up to 2 ton or 30,000 BTUs in a lot of cases, are that single stack, and then you go to a double stack on the bigger ones.
In those
So-
those 3-season rooms, the alternative would be window AC or PTAC or.
PTAC, window AC, baseboard heater, and no air conditioning at all. That's a big thing. People have that 3 seasons room. In the Midwest, we have all 4 seasons, right? So to be able to extend the seasons with that makes it a big deal. So this is Kevin's application here. His is actually a multi-zone system. So he has an A coil, just like a normal air conditioner, above his furnace that does the majority of his home. But then he has his office above his garage, so he put another head off the same outdoor unit in his office. So he's got multiple zones based off of, he's doing it with refrigerant lines and air handlers instead of doing air side zoning. So he's got a little bit different look than I do. His is a 42,000 BTU hyperheat. Hyperheat for us means the unit does 100% at positive 5 degrees, and we rate it to negative 13, guarantee the performance. He's on top of a 2005 Lennox furnace. It's a 92% single stage furnace, the base of the base furnaces when you're looking at something like that. My job that I have is a single zone system. So mine's a 30,000 BTU hyperheat, 100% still at 5 degrees, a little bit smaller of a system. My house is a little smaller than Kevin's. He's got a pretty big house. But I'm on top of a 2012 Lennox furnace, 92%. Same style of furnace, same PSC blower motor. It is builder grade. So I'm not, it's not like I've got the highest end system on both sides. I've got the highest end heat pump that you can do with one of the most basic furnaces you can do, which is a great retrofit application because there's a lot of homeowners that still have life in the furnace. And this is gonna even extend the life of the furnace even more because we don't run the furnace very much. It's only when it gets really cold. If you were to put this on a 2-stage furnace, you would get even more benefit out of it at that point.
What's going on with that PLC there?
With this here?
Yeah.
So that's actually my control board for mine. I just wanted to show a picture of that. So mine was a field trial. The contractor had never touched one of these before. It looks like spaghetti thrown against the wall. So just to show you how some of these jobs can look. And then that's all just mastic around my return air drop. So the control board in ours, as long as it's within 10 feet of the furnace is all that matters. So mine's mounted on the return air drop. Kevin's, I think, is mounted on the return air drop as well, but you can mount it on the wall. You can put it anywhere you want. So there's a lot of flexibility in terms of the installation of the system. So talking real world numbers here, does anybody have any questions about the installs before I go into the actual application numbers? Yeah.
So what happens, since you guys don't sell gas furnaces, when furnace does fail? And customer has to buy the furnace from someone else, are they gonna be able to come in and take that 2005 Lennox out and get everything all connected and hooked up the way it needs to be to run, or do you guys have to come back and get involved?
Yeah, so us as a manufacturer, we're not doing any of the installation. All our contractors are gonna be doing that. And so the contractors are gonna have their own furnace that they like using, that they like working with like that. You can leave the A coil intact, pull out the furnace, put a new furnace in if you want to. That's the benefit of us having that any coil rating, is that it doesn't matter what furnace we go over, new furnace, old furnace. These are two retrofit examples, but I've got examples that are out there already in the Chicago area that are new install, where they put a brand new furnace with a brand new A-coil on top of it. There's really no application that we don't fit into at that point. So, does that answer your question?
Well,
Or not really?
I mean, is the answer yes, it's easy?
Yes,
They just come
it's
in and
easy.
put a new one in.
Yep, absolutely.
So I've been told by other contractors, oh, you're gonna get rid of your conventional air conditioner, you're gonna go to air source, oh, we can't use your air inside, it's just not gonna work. Is that possible? I mean, we're talking ones that are maybe 20 years old, but they didn't, indoor unit furnace works fine.
Yeah.
But that.
A single stage too, right?
Yeah,
Yeah.
single stage. But we hear them say, oh, no, you're gonna have to get rid of that too, we're gonna start all over, which maybe is a good idea.
Probably not the worst idea if you've got
Yeah,
really
but
old
it's more
technology
cost,
like
obviously,
that.
Up front at that time.
Yeah,
They're
so
not ready for that.
a lot of manufacturers, their dual fuel heat pump, Daikin is a good example.
Yep.
Daikin works with Daikin furnaces. You need a Daikin furnace,
what I
it all
ran
needs to
into.
talk.
Yep.
And I had one too.
Ours does not talk like that. Ours is a 24 volt thermostatically controlled. So as long as the furnace has, and I know everybody in here is utility people, so I didn't know how in the weeds I could get technically like that. But as long as we've got a WY RGC, we can control it.
Okay.
We're not using 4-wire communication, which is what a lot of them use because it's communicating. So you would have an A plus B minus that's sending communication between each other, and then R and C, which is your ground and hot. So we work over anybody's, where a lot of manufacturers only work over their furnace. So it has to be a matched combination. Ours is AHRI rated to go over any furnace.
Okay.
So it doesn't matter 80% PSC all the way up to 98% modulating, high end, super crazy, best on the market stuff. We fit there and everywhere in between. So that's the difference when you look at manufacturers. Not all heat pumps are created equal. And I think that's one of the things that we really fight as a manufacturer is that there's, for lack of a better term, there's a lot of garbage out there. A lot of cheap stuff. Ours isn't the cheap stuff. We're just built a little bit differently. So when we talk real world numbers, so this is Kevin's numbers on here. So March to February, his therm usage, and this is at a negative 13 degree control strategy switchover. I think it's like negative 10 is where he's actually switching over at, is what he said. But he dropped 900 therms on there. He dropped 81% of his therm usage, and then you look at the cost of that. You know, his costs originally were 93 cents a therm. It went up to $1.51, so he's got a 62% cost change in there. But he was able to drop total energy. So if you took, obviously if we're burning less gas, we have to use more electricity, right? If you convert those therms to kWs, there's a formula that you can do with that, so we can look at an overall energy usage at that point. Kevin's dropped 50% year over year energy by doing that. So while we did use more electricity to heat with our reduction in gas and the efficiency of how we were able to heat electrically, we dropped a ton of usage total in the house there. Had he stuck with gas, his bill would have been $3,400, $625 more is how much he saved based on that. So big savings available with that.
There's some variables in that though, right? I mean, you're talking the weather that season compared to previous season, the commodity cost on the gas.
Absolutely.
Right? Commodities in 22 was crazy compared to 21.
Yeah, you're absolutely right.
That Texas problem in that $1.50.
You're absolutely right. Well, but what you're also doing is you're taking the volatility out of it. So like with a system like ours where we have an economic balance point that you can set, you can look at, so my control strategy is different than Kevin's. So my control strategy is based on, I took the overall, the efficiency of the 92% efficient furnace. I took my efficiency of my unit. I'm on Mid-American for mine. And I did I took what my bill was for my gas divided by my therm usage. So I took all of my costs associated with it, not just the per therm and the per kW. So I was 78 cents a therm previously to everything going crazy and about 9.5 cents a kW. So at that, I had about a 9 degree switchover. 7 degrees is what it was, but 9 degrees was my closest economic switchover point. If gas got really expensive, I could drop it down. If gas got really cheap, I could raise it up. That's the nice thing of looking at an economic balance point versus a capacity balance point, because a capacity balance point, you're stuck. You're gonna switch over when you switch over regardless of anything else. That's one of the things I like about us having that dual option. I'm telling contractors, look, when you do your cleaning checks on stuff, grab their utility bill, see what the gas price is recently, and switch that. That's part of a service you can offer to that consumer. So for me, and I've actually got some weather data on mine, Kevin didn't include his, but my first year in my home versus my second year where I did have my A-coil, at a 9-degree switchover point, I dropped my therms about 63%. I saw a similar jump in gas prices, right? We all felt that pain. We're all still feeling that pain. Natural gas for a long time, I don't have that slide today, but I've got a slide that shows the volatility of natural gas. It hasn't been super volatile over the past 20 years. Electric heating has been a more stable over that, but natural gas is right above it. Propane and fuel oil is a whole different conversation. I like comparing it to natural gas because that's our best competitor in terms of volatility and price like that. But the days of cheap natural gas are over. It doesn't matter who you talk to about that. Every field study out there, every economist, they all say by 2050, the cost of natural gas is going to go through the roof. So being able to take some of that volatility out is going to be a good thing, in our opinion at least, as a manufacturer. But for me, when I did that number, I reduced my overall usage by 26% on there. And in showing, being completely transparent, my bills did go up a little bit during that time. But it's because I paid a lot more for the natural gas I used, and my electricity went up a little bit too during that time. Now, I should have driven down my switchover temperature to a lower one, but because I was doing my own little field study on my house, I wanted it to be consistent the entire time. So I kept it at 9 degrees, regardless of anything else. I live in a subdivision. My neighbor's house was built a year newer than mine. I'm 100 square foot bigger, and they have the exact same furnace as me. So very similar. They keep their house the same temperature as mine. I was saving between 100 and 150 bucks a month on my heating bill compared to them. So even though I paid more, they paid a lot more than me. Yeah.
How difficult is it to make the economic adjustment you're talking about?
So it's function code 23. You go into the function code, the installer settings, and you change it from a 0 to a 1 to a 2 to a 3 to a 4. It's one setting in
But
there.
it takes active,
Correct. Someone has to go in and change it.
and the customer can do it themselves, the homeowner?
Depends on how savvy the consumer is at that point. That's why, you're probably not gonna wanna change it month to month, just because there's a lot of volatility there. What we're probably gonna see happen is the contractor do it at the beginning of the season when they do their cleaning checks. I think that's the best way to do it. But it depends. Some homeowners are more savvy than other homeowners. There's some homeowners that don't care, don't know, don't wanna do anything with it. There's other ones that I work with who are engineers that wanna understand everything about the system and wanna control everything themselves and everything in between.
Will
So-
you allow people to control it themselves?
At the end of the day, it's in the instruction manual. So if a consumer wants to read the instruction manual and get into it, it's not locked out. So,
I'll kind of jump in and say, while I wasn't working with the IntelliHeat controls, dual fuel controls, I have walked many of my customers through changing that over the phone at 8 o'clock at night when they got their utility bill and got home from work, and they freaked out. They've had this system for 3 years. They call me up and I can walk them through the thermostat that they have and changing that over the phone. And a lot of other contractors besides myself can do that. Any properly educated contractor will be able to do that.
yep,
It's no different than setting up the thermostat.
absolutely. It's just a setting in it just like anything else.
Yep. And there are more thermostats like the Ecobee system. That's becoming more and more available to the homeowner. And it's framed more intuitively for customer interpretation. There's a short paragraph, and then you skip through that, and then you can set your balance point in the thermostat from the user interface, not the installer settings. So it's becoming more common.
Yep, absolutely. One of the questions was around volatility in the temperatures out there. So this is Mid-American. I took this off my bill. So 2021, when I didn't have my A-coil, the average temperature was 36 degrees. The year I had my A-coil, the average temperature was 37 degrees during that time period for the heating season. So I think that's a pretty apt comparison. Granted, that's a very small sample size year to year, but that's something we hear all the time is, well, last winter wasn't as cold as the winter before that, Looks like it was for mine. And then just to kind of show like the therm usage and the cost, because there was so much volatility during that last winter, when I had 566 therms of usage without my A-coil, I paid $390 for those therms. Less than half of that the next year cost me $345. So, I mean, we all felt that pain, right? So to be able to, and heat pump sales always go up when fuel prices get volatile. You can look at it on any graph in any state. When the price of propane and natural gas rise, heat pumps rise right with them. So there's a lot of excitement. Obviously, that's why we're all sitting in this room, is because of what's going on with heat pumps right now. And this is just one more strategy that we have around it. So, yeah.
Did you do any more studies on this past year with your place?
I haven't compiled all my data yet. So, no, I haven't. I don't have the numbers ready yet. I just have my first year without it and my first year with it, because I've only been in my house 3 years. So I bought right before COVID started. So, yeah.
Well, we've also run into local contractors setting that lockout point a little high because they don't wanna.
They don't want to call back.
Yeah.
Yep.
So I think part of that's educating the contractors that, look, these things can do this, you know, make sure you're educated to do it right.
You're 100% right. And that's one of the things I like about having the ability to have both on there. You know, Kevin's is a perfect example. He set it at the lowest possible setting that you can set it at. And when it can't keep, because what the contractor wants to avoid is a callback, right? Because they don't make money on callbacks. They set it up wrong, and I say that with air quotes. They didn't set it up wrong, but the homeowner thinks that. And so they're gonna have to go out for free, take time out. As you said, there's not enough hours in the day, there's not enough help. You don't have enough people to do it. So having that strategy of being able to do lowest, economic lockout, and then when it can't keep up anymore, you've got a fail safe in there. So it's gonna come down to education, because every system's a little bit different. We're the only one that I'm aware of that has that economic balance point like that. Everyone else, you set a lockout temperature, and everyone's gonna set it a little high, because the last thing they want is the call at 9 o'clock at night, I can't keep up anymore. So, yeah.
So you talk about the education piece, and you brought up a good point, Zach, that time to send people to school is very limited. And in Iowa, a conventional furnace and air conditioner, what people are comfortable with, and people sell what they're comfortable with. Like, one, time's an issue where you're trying to have to educate a homeowner or a business owner on it different than what they know. It takes more time. Meanwhile, the service or sales guy has 10 other calls that they have to hit before they get to go home that night. So that, I think, is an issue. However, I think money drives a lot of decisions, especially for small business owners. Do you see the Inflation Reduction Act, and I know there's a session later on the day talking about how that's going to be rolled out in Iowa, but I was just pulled up the Rewire in America calculator while I was sitting in here, and we talked about low-income homeowners, but for somebody making $65,000 a year in West Des Moines, the Rewire in America says there's going to be an $8,000 rebate available for a heat pump, not to mention a $2,000 tax credit, plus maybe a utility rebate on top of that.
Plus another $4,000 for the wiring and the panel.
Yeah, if I'm an HVAC contractor and you're saying it's $8,500 to sell it, I'm thinking, well, I can sell this for $12,000. My margin goes up, so I'm going to start incentivizing my salespeople. Like, do you start to have those economic questions with these, especially small business owners, to say, hey, like, jump on board, you can make some serious coin here. Like, let's do this. Like,
so
that's the entire contractor value proposition.
Right.
Because the IRA it's the keynote speaker earlier, he said he's not here to be political. You start talking IRA, it gets political, right? I mean, I spoke in front of HACA in Omaha 2 months ago, and one of my contractors came up to me afterwards and thought, I thought you were going to need armed security to get you out of there. Because I'm talking IRA, and all these, very, very conservative contractors are, just pissed that this is out there. And my whole speech that I do about this, look, I'm not red, I'm not blue. The only thing I worry about is green. The money is there. You can stick your head in the sand and say, I'm not going to do it, and put your feet in the, great, your competition's not going to. The money's there, whether you like it or not. It's probably going to get refunded because these programs always get extended. They never get sunset. Let's be realistic, regardless of who's in the White House. This is a big strategy for Mitsubishi. I can't speak to other manufacturers. I can only speak to us as a manufacturer. We had our national sales meeting in New Orleans 3 weeks ago, and our CEO stood up there and said, our goal is that plan that you're talking about. Mitsubishi wants to capitalize on 50% of the money that's out there. That's our goal as a manufacturer. And that sounds crazy, but when you look at the utility rebates that are out there, we average about 60-65% of the utility rebate money that is driven towards stuff like this. Mitsubishi gets that. So we'll actually underperform if we hit 50%. There's a program in Wisconsin right now, Focus on Energy has one. We're getting over 65% of the Focus on Energy dollars as a manufacturer because of how we educate our contractors, the value propositions that you're talking about. Our equipment hits the criteria in multiple ways with multiple pieces of equipment. We're geared to go after these programs. The IRA is a great example. Our CEO came from our utilities division. Actually, Kevin DeMaster took the job over when Mark Kuntz, our CEO, got promoted up the chain. So that our CEO understands that background. He helped design the IRA. He was in Washington and was instrumental in it. So, like I said, I can't speak to other manufacturers, but for us, we are doing backflips over this right now because of the potential that's out there. I mean, we did $1.6 billion in the United States last year as a manufacturer, only selling heat pumps. We plan to be $5 billion before 2030. And IRA is a big portion of what's going to get us there because there's so much money out there. Yeah.
Question. So, you're a company. You want to protect your intellectual property, playing, like you talk about other manufacturers, playing nice together and being able to integrate together. I see in the marketplace a lot of manufacturers who, and maybe this speaks to how you're educating and working with the contractors, what's being done to take, say, I have a 6-year-old furnace. This is interesting to me. I still have, potentially have a warranty. Have a service contractor with a contractor that I already work with.
Mm-hmm.
How are you creating that relationship in which you can bring, is that same contractor pool, just think big contractors in the Des Moines area, that same contractor pool, they have the ability to basically sell another product that's because a lot of times you're seeing more and more and more in the marketplace, the contractors can only sell, if you want to sell a Amana, you can only sell Amana.
Mm-hmm.
How are you getting over that, especially when you're looking at really not just being a sole source for your own equipment in a home, but that retrofit, playing nice with that existing equipment's manufacturer and navigating that.
That's one of, I think, our unique value proposition with this product is we're telling people, so with other manufacturers, they're saying, ditch your unitary manufacturer, right? People are married to their unitary manufacturer. There are, Lennox started in Marshalltown, Iowa. I've got contractors I work with that are 100-year Lennox contractors. You think they're switching away from Lennox? There ain't no way. But when you say, look, keep your gas, keep that system you've always put in like that, let's look at upgrading your heat pump part of it. Keep your furnace, but let's do this part of it as well. It's really gives us a different way of looking at it. People aren't married to their heat pump like they are their furnace. I mean, people tattoo Carrier across their chest. I've yet to see a Fujitsu tattoo on somebody, right? So that's where we're a little bit different because we're not asking anyone to change their business like that. We're just asking them to add something else onto it. And the unitary manufacturers as a whole, they haven't done a great job with heat pumps. They don't have cold climate available in a lot of cases. A lot of their stuff is not inverter, and if it is, it's behind the curve. They don't do 100% at +5. They don't have those higher COPs. It's just a little bit different thing. So that's where we partner with we didn't want to limit ourselves. My favorite contractors to work with, if you ask me personally, I love Lennox contractors because they're used to selling high end, and Lennox has done a really poor job of heat pumps. So I've got an in with every Lennox contractor that I walk in the door because I know their pain points and I know how I can help them overcome them. And I'm not asking, hey, don't sell Lennox. I mean, you get kicked out the door immediately if you said something like that. So yeah, I think I can only speak to me as a manufacturer. We just operate a little bit differently because we're not asking people to switch that part.
All right. Go ahead. Yeah, we've got one more minute.
I'm going to expand on that little term too, because as a contractor, when you sign up to be a Lennox dealer, as an entry-level dealer, you're not obligated to sell a certain percentage of your product to them or their product through your sales. When you become like a premier dealer, the contracts only say that you have to sell 60% of all your sales have to be Lennox. So they're not 100% locked in. And any company, any manufacturer who's gonna lock someone in like that, it's just gonna lose, they're gonna lose contractors. No one will willingly engage in a contract like that, where you're that limited.
All right, it is actually 12 o'clock on the dot. If you have any additional questions, feel free to stick around and ask Sly and Zach. But
Yeah.
thanks, guys, for being here. Good job.